And I want to talk about reference architectures. Okay? Got to be about the driest topic known to man. And I'm sure you were hoping that I would tell you, why doesn't it want to go forward? Let's try that. That worked. The Huawei, and just to clear it up, it's Huawei. Okay? I get Hawaii, okay, so, which it certainly isn't. Is going to come here today and tell you something wonderfully new about reference architectures for Lustre. I hate to disappoint, okay, because I won't be telling you anything new about a reference architectures. I'll just be telling you what we're capable of doing. Okay, and I will look at a different approach, however, drawing on some of the input we saw earlier in the day from Intel when they were talking about using JBots instead of using controllers. And I've got a shopping list of what you need for about a 1.5 petabyte solution running at about 96 gigs bandwidth for that particular reference architecture. So essentially, it's our reference architectures are unsurprisingly like everybody else's. It's fundamentally a walk through our storage controller architecture. To get to high bandwidth, you need more high performing SANs. Okay, we have 5 levels we've got to walk through to get to the highest possible levels, because there are 5 various steps in the SAN controller architecture that we can bring to bear. So we can put up to 16 controllers in the architecture, okay, and shows a performance there of 96 gigabytes bandwidth per cabinet, and I'll show you that particular one when we go to look at the at a JBOD based approach as opposed to using a SAN based approach. I'm going to use this. Okay, so we talked about when the Intel, my Intel colleague was giving the presentation, the entry level, the small scale. Okay, we equally have a small scale architecture, and it looks exactly like what he was proposing, not what to do. Okay, so I liked his input. I will go away, and Michael and I will talk to the factory about looking at that small form factor solution for those clients that need a solution at that lower end. But that is very much the traditional. And like I said, essentially to get to high performance levels and greater capacities, we do a basic walkthrough of our controller architecture. So I won't sit here and bore you with speeds and feeds, especially mindful of the fact that you're all keen to go, okay, and the fact that, that there is at least coffee coming a little bit later on, okay, and then we get bigger again, okay, depending on what your particular requirements are. But we do get to some more interesting, there's one more for you to have a quick look at, and of course you'll get this slide set so you can look at it at your own time. This is the more interesting approach. Okay, this is approach using ZFS and JBOD. Now there is actually, believe it or not, a hole in the Huawei product line. We don't do a JBOD, okay? It's about one of the few things I've discovered we don't do. They can do wonderful running phones, okay, but we don't make a JBOD, all right? So in fact, for this particular reference architecture, if anybody recognises what an SP3584 is, raise your hand. No hands raised. It's Seagate. Okay, so we're using a Seagate JBOD for this particular solution, and essentially in a rack, we're looking to provide 36 gigs worth of sustained performance across 1.5 petabytes usable with a shopping list that looks something like that. Okay, and I'll give you a moment to contemplate all those various bits. Okay, and we're fully on board the Intel Enterprise Edition Lustre bandwagon. Okay, so you'll see there's an IML server in there. Okay, and that's how we deliver the solution with a combination of those Seagate JBods, Huawei servers, and in terms of networking, you will be unsurprised that we OEM Mellanox. Okay, so while Huawei is known very strongly in the IP networking space, it is not what we bring to bear in the high-performance computing market. So, of course, the thing is that if I think of an Australian context, okay, most of you think HPC, Huawei, don't really have any experience with that. Don't know whether any of you have had the chance to visit Poznan Supercomputing Centre. It's about a Ryzen class machine, so that's a Huawei system. Curious enough, I don't actually know what they use for a file system. We didn't supply them Lustre. Okay? So the various case studies that I brought to bear here are places where we have provided Lustre-based solutions using the sort of reference architectures that I've been demonstrating to you during the course of today's very brief presentation. And you'll see that we have quite a few in Europe. Okay? We've been operating in the HPC environment in Europe longer than we have in the Australian marketplace. I joined Huawei precisely 8 weeks ago as their National HPC Business Development Manager. And for those of you that don't know me, my name's Clarkson. I just realised I forgot to introduce myself at the start, which was particularly clever of me. Okay, so University of Newcastle, in Newcastle, not to be confused with the one that's somewhat north of us here. Okay, now I'm going to call on Michael to give me the correct pronunciation of BJTU. There you go. Alright, so a Chinese reference where we've delivered a Lustre solution. Michael's English is impeccable. Michael Yang, Solution Architect with Huawei. My Chinese is non-existent, so I doff my cap to Michael. Yildiz Technical University in Turkey, another one you can see, interestingly enough, I mentioned there were 5 levels in our storage technology. So we start off with the lowest level with a 2,000, then we move to a 5,000, an 8,000, a 9,000, and 18,000. So that's how we progress through the ranks, bringing more performance to a SAN environment with those different levels.